So we have looked at how we sense information. We have looked at how we perceive information and how we use attention to choose some subset of all the information that we sense to make it the focus of our consciousness. And we have looked at how we hold on to information either in the short term or in the longer term. What I want to focus on today is how is this information and how is knowledge represented inside the human mind. Now, let me start with an example. Take the following sentence, and as I read it, picture this in your mind. Aisha was walking home from the park when she fell, and the balloon she was carrying floated away. Picture this in your mind. Now, let me ask you a few questions. How old is Aisha? What did the balloon look like? What was the color of the balloon? And also, what was inside the balloon? And see, the answer to these questions is surprisingly predictable if you ask a large number of people, even though that the sentence I read to you doesn't contain the answer to any of these. Yet, what you probably conjured in your mind, because most people do, was something like this. Right? Aisha is probably a child in your mind. And why did you think a child? Well, probably because you have schematic knowledge, as we will see later, that children tend to be more likely to be carrying balloons as compared to adults. The balloon, what color was it? Probably red. Why? Well, it could be other colors. Red is just a very typical color for a balloon, nothing else. Also, you probably inferred that the balloon in it must have had helium and not oxygen because it floated away. And see, this is a nice example of how we use knowledge that we already have in order to represent the world. And see, the fact that these answers are so predictable on average tells us that how knowledge is represented in our minds has to be, in a sense, has to have a regularity in how it's organized. Also, it tells us that we use a lot of previously stored information. All the experiences you've had of seeing balloons is probably what led you to believe that the balloon being red was a good guess. Similarly, there's a lot of implicit knowledge. You know what children typically do. You know what a balloon looks like. You know how a balloon responds to an environment, et cetera, et cetera. So in this sense, there's a lot of the fact that these answers are predictable tells us a lot about what must be the structure of knowledge inside our mind. And that is what I want to focus on today. Now, before doing that, let me start with some basic vocabulary. First, a concept. Now, a concept, this is really the fundamental unit of knowledge inside our mind. And it's really a mental representation of, something, an object, an idea, an event. A concept might look something like this. The concept of cat, for example, is attached to some exemplars of cat. You have there's this type of cat and this other type of cat. Now, it also has certain features. For example, it is furry. It has a long tail. It might have a long tail. It might be furry. It doesn't necessarily have to, and we'll get into this a few slides down the line. Also, some things that cats might do. It might meow. It might never say a peep, but it might meow. And so this is what we mean by a concept, sort of a web of features that relate to each other. And also within concepts, we often distinguish categories from exemplars, with categories being sort of some kind of grouping on the basis, some kind of grouping of objects, of ideas, of events, some kind of grouping on the basis of some type of perceptual, biological, or functional similarity. Essentially, a grouping of individual objects, ideas, or events on the basis of some feature. For example, cat is a category. And within the category of cat, there might be different exemplars of cat. Well, there might be calico cats, there might be Siamese cats, et cetera, et cetera. So in a sense, the exemplar is the individual example of a cat. Now, you might notice also that this concept that has certain features attached to it, there might be other concepts that overlap with the features. For example, the concept of dog also might have features such as long tail and furry attached to it. So in a sense, our knowledge is a broader web. You might also appreciate that dog and cat, of course, are categories. Within the category dog, you might have different types of dogs. Same for the category cat, as I said earlier. But dog and cat in of themselves, however, not only are categories, but they're also exemplars of the category pet. Right? You might have pets. Within pets, well, pets are a category, and within the category of pets, you have certain exemplars: dogs, cats, hamsters, goldfish, etc., etc. And of course, pets in of itself is actually an exemplar of the category probably of animals. So how is this implemented in the human mind? Well, one of the very first theories, really dating back all the way to Aristotle, typically referred to as the classical view of categorization. The idea is that in our mind, we have lists of features, and in order for you to be part of a category, you have to abide by these features. So there might be some necessary features, and you've got to have them. If you don't have one of these features, you can't be a member of the category, and there might be sufficient features. If you have any of these sufficient features, then you are a member of a certain category. In this sense, this says that the way in which our mind represents a category is very abstract. The way in which we represent the category, has no information about this or that exemplar, this or that item. It's an abstract list. Let me give you an example. Think of a square. What does it take? What is the list of features to be a square? Well, for one, you have to have 4 sides, right? If you don't have 4 sides, you can't be a square. You also have to be a closed figure. Even if you have 4 sides, you have to be a closed figure. Else you can't be a square. You do have to have sides that are equal in length, else you're not a square. And not only that, you need to have sides that are equal in length, and the angles have all to be the same, all at 90 degrees, else you're not a square. Okay? So in this case, it's very straightforward what makes a square. There's a series of features, and you have to have them. If you don't have them, sorry, you're not a square. You're something else, not a square. However, if you think further of this approach, it becomes problematic very quickly. Think about what are the defining features to be a bird. Well, how about gotta have wings, gotta fly, gotta have feathers, perhaps singing, gotta build nests in trees and eat worms, insects, etc., etc. And I'm sure we can perhaps keep going and find a number of features that would make a bird. However, it becomes rapidly apparent that not all birds do this. Not all birds have all of these features. Clearly, this bird I show here, yes, the typical bird, it does have these features, but some birds definitely have a very few of these features. Penguins don't have wings, don't fly, don't build nests in trees, don't eat worms. So, and yet, they clearly are birds. So see, this must expose a key limitation of this theory. It's really hard sometimes, perhaps even impossible at times, to find a clear, finite, and complete set of absolute defining features for many categories. And yet, I'm pretty sure that if I filled up the screen with pictures of birds and non-birds, it would take you a millisecond to tell apart if something is a bird or not. So clearly, this cannot be the way in which our mind achieves classification and groups information. It cannot be that in our mind there are these type of lists. And see, there are other important ways in which this theory does not seem to capture how our minds work. One good example is the notion of typicality. Look, if I were to tell you, hey, look, there are 2 birds on the branch, you probably are thinking this. Yet, could have thought this. It's just not what your mind did. That's just not where your mind went. And see, this idea was captured later in the lab by Roche in 1975. And the idea is that if you give people a list of animals and you ask, for example, a list of birds, and you ask them how birdie is, and then ask them, and then show them each animal, you find out a couple things. First, that people give you different ratings for different animals. Second, people tend to be very systematic about, or rather across people, it's quite systematic what rating they give to each bird. So for example, a chicken is kind of like, not great. Robin, typically great example of, birdiness. Bat, typically pretty far down. Ostrich, also not great. Eagle, pretty good. And see, a couple of things should have jumped out at you. First, if we categorize thanks to an abstract list in our mind of features, it makes no sense for any of us to have different ratings as to how birdie something is. Either you are birdie because you have all the necessary features or you have some sufficient feature, or you're not. You're either in or out. There's no sense in which you can be more or less birdie. And so in this sense, it should not be that different exemplars can be better or worse examples of a certain category. As I said, what is striking is that people, at least within the same context, and we'll get to this later on, tend to give very similar ratings of where a certain example falls within a category, whether it's a very good example or a bad example of a category. And finally, hopefully you were horrified when I didn't flinch and even gave an actual rating to bat as a bird, because obviously bats are not birds. Yet, so tempting to think that it is. And in fact, many people might not know that a bat is actually not a bird. So clearly, this shows that the classical approach just does not reflect how our minds think about categories.